Hey guys, today we're going to talk about applications of quadratics and falling objects, projectile motion. So we have a general formula for projectile motion, and I will explain the pieces in just a minute, so don't worry. So h of t is equal to negative 16 t squared plus b sub 0 t plus s sub 0. Now, this looks intimidating, but it's still just standard form of a quadratic. But we need to know what all this stuff stands for. So I'm talking about an object falling from the sky. H of t is our height. What height is the object at? T represents time. V sub 0 is what's called the initial velocity. So velocity is like a force that you put on an object. So when you drop an object, there's no velocity. But when you throw an object, you're putting a velocity on that object as it goes sailing through the air. And S sub 0, that is your start height. So if I drop an object from 5 foot in the air, 5 would be my S sub 0. If I drop it off of a 20-foot building, 20 would be my S sub 0. Okay, vertex. This is still standard form of a quadratic. It just doesn't quite look like it. Vertex is our negative b over 2a. And then we plug that in to get y. But now, let's put it in falling object motion. Vertex, when I think about my parabolas, my vertex is this highest point. So the vertex is going to give me the max of the object. Now, I am going to take this just a touch farther. It's not only the max of the object, the x value is the when we reach our max height. And the y value is what is the max height. Okay. The y-intercept. This is the value of y when x equals 0. But when we're talking about a falling object, we're not talking in terms of x and y anymore. We're talking about time and height. So the y-intercept is the height of an object when time is 0. So at the beginning, if I drop my keys from a 20-foot building, the initial height, the y-intercept, would be the 20 feet. X-intercept, this is the value of x when y equals 0. So again, in terms of our falling object, this is going to be what time does the object hit the ground. And how we're going to find this, we're going to factor. So, before I start an example, I hope you'll see, especially in this first example, that none of the content is new today. It's just we're putting it in terms of a word problem. We're talking about height and time, but we've found the vertex of a quadratic. We found the y-intercepts. We found the x-intercepts. We've done all this work before. We've factored everything. It's just now we're putting it in terms of word problems. So I have an object that's launched from a roof 160 feet above the ground with an initial velocity of 48 feet per second. First thing I ask you to do is write an equation. Well, to write an equation, we're going to use this projectile motion formula. H of t equals negative 16t squared plus Velocity. Are we told the velocity in this problem? Hey, right there it is. So I'm going to replace the v in my equation with 48 plus s. S is our start height. Well, are we told the start height? We are. That's their 160 feet. Once I have my equation written, I don't need to use the word problem anymore. Everything is going to be off of the equation. So here's my A, B, C. What is the vertex? Well, to find vertex, I know I'm going to get coordinate x, y. Well, I have to find the stuff first. X equals, we used a little baby formula. So negative of, what's our B term? Over 2 times, what do we have for A? So I've got negative 48. I made this way too big. Negative 48 over negative 32. And when I divide that, I get 1.5. So that's the x value of my vertex. And then what did we do to find the y value? Once we know x, we take what x is and we plug it in. We're going to type that in our calculator, and we get that y equals 196. So that's the y value of my vertex. So now part C and D, we actually already have the answer. We found them in part B. I just need to know how to interpret them. When did the object reach its max height? The when is our time. When are you going to the store? That's a time. When did the object reach its max height? What time? Time is always our x value. What time did our object reach its max height? At 1.5 seconds. What is the max height? That is your legitimate height, which in this case is our y value. So what is the maximum height that we reached at 1.5 seconds? That'd be 196 feet. When will the object reach the ground? Well, reaching the ground means that my height is 0. When is a time. So I'm trying to figure out what time is my height equal to 0. So what we're going to do is we're going to take our equation and we're going to set it equal to 0. And in order to answer this, we're going to, actually, we'll do that. Yeah, I'm going to move that over there. Sorry. In order to do this, we're going to factor. Now, I'm going to tell you all, you're going to be able to take out a constant term of all these terms. So we're going to try 16. 48 divided by negative 16, negative 3. 160 divided by negative 16, negative 10. Now I have something that's a whole lot prettier to factor. I factor by taking A times C. I need factors of 10 that add to 3. Negative 5 times 2 is negative 10. That's good. Negative 5 plus 2 gives us our negative 3. So now we split. And we group. So then my factors are t plus 2 and t minus 5, but factors are not our solutions. what do we do with our factors to get our solutions? We set each one equal to 0. And we solve them separately. So we end up with t equals -2 and t equals 5. But you have to think about this a little bit. What does t stand for? T is time. Can I have negative time? The answer is no. So my answer for when does the object hit the ground? It will hit the ground at 5 seconds. Now on this first homework assignment, I didn't make you sketch, but I'm going to show you how the sketch is going to work. So that tomorrow's lesson is a little easier. So when we plot a point, we think of X and Y. But for these motion models, we don't actually have X. Look at our equation. What's in the place where we normally see an X? That's T. So that means time is going to be down here on our X-axis. Y, but what's in place of where we normally want Y? That's my height. Okay, so to make our sketch, we're just going to pull the information that we have. When time was 0, what was our height? Where did we start at? So in this case, we started at 160 feet. So at time 0, I'm going to put a dot at 160 feet. Then we have a vertex of 1.5, 196. Yes, I will let you label your y-axis this way. And then what's the next information we found? That we hit the ground at 5 seconds. So at 5 seconds, I have no height. I got a nice, pretty parabola. Which, think about it this way. We crossed out the -2, so the -2 would be back here. Do we get our parabola like what we're used to getting? Yes, it's just we don't need this back portion of the graph because that's when time was negative and time cannot